So dear students, we have done with the starting basics questions and as also the examples I am having here. We have done with the question number 7 in the example, right? So I am having question number 8, 2, 9, 10 and question number 9, 10, right? These two questions for the illustration, right? So I am having 8, 9 and 10. So I am having here 3 questions for the illustration related with the analytic function, my dear students. So right, let us have the question number 8, which is asked in the IIT Roorkee 2009. The analytic function of the complex number z is equal to x plus iy is expressed as the function fz is equal to this, I is equal to root minus 1 if u. So here it is given fz is the analytic function, so it is nothing but u plus iv, dear students. So let us have the equation number 1, and also we are given with the real part. Here we are given with the real part, and the real part is nothing but u is equal to x into y. Fine, the real part is nothing but x into y. So what is the value of v, dear students? What is the value of v? And we have the 4 options. We need to calculate the value of v here. Okay, now v is question mark. So I have given you the concept actually. If it is given with the real value or imaginary value and ask the another real or imaginary value, then we can apply directly CR equation. Fine. So what is the CR equation? I am having CR equation because this function is what? Analytic function. So if the function is analytic function, then we can apply CR equations. So what are the CR equations? CR equations are nothing but del u by del x is equal to del v by del y, as we have the previous video. Also, so I am dividing it. Also, we are having what? Del u by del y is nothing but del v by del x, but with minus sign. Fine. So this is nothing but CR equations, right? So let us have. So del u by del x is nothing but y. So here you can say del u by del x. So del u by del x is nothing but y. So y is equal to, we are having what? Del v by del x. Okay, del v by del y, I am sorry. So it is nothing but del v by del y. So here we can say del v by del y is equal to y. So here you can say, I am implying like this. So del v is nothing but y into del y. So here by the there is no there is nothing like this. We are having the value of, if I am integrating this, partial integration, right? So we do not have the concept of partial integration. My goodness. So if I am integrating this, so here you can see for value v and here you can see for value y, the x is constant, so I can apply a constant as a function of x, my dear students. Here is the concept. This is not the partial integration. In the integration there is not a partial integration. So here you can see for v and y, if v is the function of x and y as given, please read the question number 8. The fz is nothing but u xy plus I v xy. Fine. It is u xy plus I v xy. So you can say v is the function of x and y both. Here we are only integrating with respect to v and y. So x is a constant. So here in the form of the integral constant, we should apply the function of x, and that is nothing but phi x. Fine. So here you can have the value of v. I am having the value of v is nothing but y square by 2 plus this function phi x. I am having the equation number 2. Fine. So this is nothing but the value of v. We are having the value of del v by del x. So you are having here del v by del x is nothing but del u by del y, and del u by del y here by here you can say del u by del x is nothing but y, and del u by del y is nothing but v. Okay, not v, it's x. So del u by del y is x and del u by del x is y. Fine. So here we can have minus. So I am applying here minus. So del v by del x is nothing but what? Del u by del y with minus sign. And what is the value of del u by del y is nothing but x. So I am having here x. Now what is the value of v? So the value of v is nothing but y square by 2 plus phi of x. So I am having the value of v here, I am putting the value of v here. So this is del by del x, and the value of v is nothing but y square by 2, this is y square here, y square by 2 plus phi x. So this is what we are having, what, phi x, and this is equal to minus x. Now I am differentiating with respect to x, and I am getting what, phi x differentiation, and it is nothing but minus x. So you can say what is the value of phi x by integrating. I am having what, x square by 2. See, by integrating what I am having, the integration of x is nothing but x square by 2, but here we are having the integral constant and it is nothing but k. So from equation number 2, put the value of phi x. So what will you get is nothing but v is equal to y square by 2 minus x square by 2 plus k. So here I am having x square by 2 plus k, or we can say v is equal to y square minus x square whole divided by 2 and plus k. So this is nothing but the imaginary part. I am repeating this question again, please see, because in offline class also for some students I am repeating this again for you also. So my dear students, here we are having the u is equal to xy, so del u by del y is equal to x, and del u by del y is equal to x, and del u by del x is equal to y. So v is question mark. So by having the real function, or by having the real part, if we need to calculate the imaginary part, directly we can apply the CR equation. So I am applying the CR equation in the red color. You can see del u by del x is equal to del u by del y, and del u by del y is equal to minus sign of del u by del x. This is nothing but the CR equation. So I am speaking fastly right now. Del u by del x is nothing but y. So here you can have del v by del y is y. So I am having del v by del y is equal to y. So this is what the partial differentiation. So we do not have the term partial integration, but yes, if we need to apply the some constant. So for v, if it is differentiable, if it is differentiation with respect to y, then definitely the x should be the constant. So here I am applying phi x as a constant. So now this is the value. Now we need to evaluate the value of phi x. So here I am using this second equation. By this second equation, definitely we can have the value of phi by putting v is equal to this value, and now phi dash is equal to minus x, so phi is equal to this. So this is, let us suppose I am equation number 3, we are having equation number 3, and this value is from equation 2 and 3, from equation 2 and 3. Fine. So this is our answer. Let us check the option first. So in my mobile I have the workbook. So if I am having the answer, this is nothing but option C, y square minus x square by 2 plus k. This is what we are having here, option C. Fine. Let us have the question number 9. I am having the question number 9 in my workbook. The question number 9 is, it is exactly related, and it is asked in the, after this GATE 2009, it is in GATE 2009, and this question is asked in GATE 2010. So I am having what, the f x plus I y, it is given is equal to x power 3 minus 3 x y square. Okay, it is looking like the previous example, the z power 3, remembering. Okay, let us have, okay, I am having plus I phi of xy. So this is what our imaginary part. So here we need to evaluate our imaginary part. Fine. This is nothing but part v. So we need to apply this, we need to evaluate this, right? Fine. Okay. So here this is the function, and I am having with u, and u is nothing but x raised to power 3 minus 3 xy square. So you can apply directly by CR equation, and here I am having u, I am having u, and del u by del x. Let us have the del u by del x is nothing but 3x square minus, with respect to x I am having 3y square also. Fine. So with respect to x, 3x square and 3y square. Okay. Now, okay, what will be the value? So del u by del x for CR equation, it is nothing but del u by del x for CR equation. Okay, del u by del x I am writing. Okay. Del u by del x for the CR equation is nothing but del v by del y, and del v by del y is equal to, we are having 3x square minus 3y square. So here you can say x is not the constant because here I am using the x, so directly we can integrate it, right. So with respect to y, or we are having here what, v dv, in fact dv I am writing again, please you can see here why I am not applying this constant as a function, because here you can have x also and y also, so directly I am integrating it, right. So I am having dv is equal to integration 3x square minus 3y square, and yes, it is what with respect to y, and let us have plus k. So I am having v is equal to, with respect to y, what is the value, 3x square y, and minus with respect to y I am having what, 3 into y raised to power 3 divided by 3 plus k. So what will be the value of the imaginary part, dear students? So this is nothing but I am writing here v is equal to 3x square y, so you can write like 3x square y, and again 3 and 3 cancel out, you can see here 3 and 3 cancel out, I am having what, minus y raised to power 3 and yes plus k also. So this is what we are having the answer. Why I am not, actually why I haven't take this value, let us have the answer first. Option B, 3x square minus y raised to power 3 plus k is not available, so there is no problem at all. Now why I am having directly what we can say the integration here, because here y is the v is the function of x and y. See, v is the function of x and y, and here x and y both are available, so directly we can integrate it, there is no problem at all. So in question number 10, what is the question number 10, my dear students? I am having the question number 10, and question number 10 is nothing but, let us have the question number 10 here, and question number 10, in question number 10 we are having what, analytic function of a complex variable expressed by this fz is equal to u xy, so I am writing u plus I v xy, so I am writing here v, and this is number equation 1. Now in question number 10 it is given that u is equal to, that means u is nothing but x square minus y square, and general constant c and v should be the question mark. So here the v should be our question mark, okay, exactly v is the question mark. So again in this also v is the question mark, again in the question number 9 also v is the question mark, in question number 10 also v is the question mark. So I am applying the CR equation in question number 10 also. So let us have the CR equation. So what is the CR equation? Is nothing but del u by del x is equal to del v by del y, fine, because this is the value. I am applying CR equation number 1, and let us have the number 2, what, del u by del x. So del u by del x is right, so I am having here del u by del y, fine. So I can write del v by del x is equal to minus sign of del u by del y, there is no problem at all. And also with what, with the need to evaluate the value of y here, I am taking y as a left hand side, so I am writing del v by del y is equal to del u by del x. So what are the CR equation? Do not get the confusion, right? Del u by del x is equal to del v by del y, fine, and del u by del y is equal to minus of del v by del x. So here you can see this value, okay. Now applying here, so del v by del y is nothing but del v by del y, because we do not have the del v, we do not have the v, so I am applying like this only, and del u by del s is nothing but 2x, so I am having here 2x, okay. So we are having here y, v and x already, so we are having directly del v is nothing but 2x and del y. I am integrating and putting here c, the value is what, v is nothing but 2xy plus c. Let us check the answer. Let us check the answer in option. We are having option C, that is 2xy plus c is the correct answer. So we do not have the here, what is the here value I am having here, the constant. Why I am having the constant? Because in this we are having y, we are having v and also the x, so we can directly have the value c. But here in this it is very important, the question number 8 is really important. Why it is very important? You can see here in the illustration or in the example I am telling you that if del v by del y, and here v is the function of x and y both, and I am doing what? I am taking the x as a constant. So the constant will be the function of x. So this is the main concept, right? So in this question we have the concept, and again in this question we can directly apply without using that. So this is also the short trick, you can say it is, we can directly apply without having the constant term or without having the two CR equations. But here in this question please repeat it, please make the proper notes, and also remember this red step. It is very important when you are having v as a function of xy, but we are only having the differential with respect to y. That is why x is here as a constant term, my dear students. So I am putting phi x as a constant term, or in the place of the constant we are using here phi x, dear students. So that's it. So that's it. I mean that is related with the analytic function. But yes, let us have the I'm having the experiment in question number 8. So I'm having the experiment in the sense what? In the sense what? If it is asked to evaluate the analytic function, fine. In question number 8, I am given with u, I am writing here, I am given with u is equal to xy, and I am saying what? If it is asked to evaluate fz, that is the analytic function, in form of z, let us suppose, fine. If the options are in the form of z, I am wiping that question number 10 and then I have the experiment. So you can say, if I am having here u is equal to function of xy, my dear students, I am having u as a function of xy, fine, u is a function of xy, fine, u is a function of xy, that means u is nothing but xy, but we need to evaluate what? We need to evaluate directly fz. Then what should we do here? We need to apply the Milne Thomson method, because we are given with the real part, and from real part we need to evaluate the analytic function. So this is nothing but formation of analytic function. So this is my experiment. I am having formation of analytic function. So it implies in the method, and this is nothing but Milne Thomson method. So let us apply the Milne Thomson method. You are given with the u is equal to xy. First u is equal to xy, then we need to have the value of del u by del x and del u by del y first. So I am having del u by del x, it is nothing but y, and del u by del y, it is nothing but x. Now what I am doing is I am having the Milne Thomson method. So let us have the fz is nothing but the analytic function. It is u plus iv is a analytic function I am having directly. So what is the value of f dash z? I am having del u by del x plus I into del v by del y. Please repeat. If you are not getting it in the flow, please repeat the analytic function I have told in the previous videos. Fine. In the last video we have the example of analytic. Before that, in the previous video we have the concept of analytic function, dear student, and in that video we will have the Milne Thomson method. So I am having here. So we need to change that this del y or del v by del y, I mean we need to change this, because we are only having in the form of u. So I am having del u by del x, there is no problem with it, and del v by del y is nothing but, you can say, del v by del y, right? So del v by del y, oh no, here is a big mistake I am having. Okay, it is with respect to x. Okay, so it is what? Del v by del x. Okay, now what is the value of del v by del x? So del v by del x is nothing but del u by del y with minus sign. So I am having what here? Del u by del y. So let us put the value. So I am having f dash z is equal to del u by del x is nothing but del u by del x, right? So it is nothing but y minus I, and del u by del y is nothing but x. So what to do with respect to x or y? No, here is the assumption, and I am putting x is equal to z and y is equal to 0. So now what I am getting is, by putting this x is equal to z and y is equal to 0, what I am having, f dash z is equal to, this value is 0 minus sign I, not the vector, yeah, it is simple I, right? So it is I, and what I am having is the x, and x is nothing but z. So now integrating with respect to z, I am writing integrating with respect to z. What I am having is, this is nothing but fz and is equal to minus I, and yes, z square by 2 and plus you can have here c. So this is the analytic function in the form of z. So this is nothing but the analytic function in the form of del z, dear student. So fz is nothing but I z square by 2 plus c. Fine. So this is what we are having, the Milne Thomson method, because in the GATE examination there is 0 questions related with the Milne Thomson method. So I have changed this question. In this question it is asked to evaluate the value of v. The value of v is nothing but, this is the option number C. We have solved the question number 8, right, of the booklet, but in question number 8 I have changed the question. The real part is given and you have to find this analytic function. So the analytic function is nothing but this value. Now it is not the end. Now let us have the value of z. I am putting here the value of z, my dear students. So what is the value of fz? Let us have the value of z. So I am having minus I by 2 x plus iy whole square plus c. What I am having is, minus I by 2 is out. So this is nothing but the whole square. I am having x square minus y square plus 2i xy and again plus c. So here you can see also the, if I am multiplying this two value, right, if I am multiplying this two value, this is nothing but I square, that means what, minus 1 and minus plus. So I am having what, xy, and this 2 and this 2 cancel out. So plus I am having what, I is common. So if I is common, we have this value changed, swapped. That means what I am having is y square minus x square by 2, and this is what, plus c. So you can see here what is happening. You can see here what is happening. This is what, see what I have done right now. I was taking the real part and I have changed the function. That means what I am applying is the formation of the analytic function. The formation of analytic function is nothing but Milne Thomson method, and yes, I have the answer, right? But yes, by putting z's value here, x plus iy, and squaring it, I am having this value, and you can see here, this is what the value of u which is given, absolutely fine. And this is what because we do not use the I, because in the real part and imaginary part, both part are real. So I am having the imaginary part is nothing but like this. So here you can see the imaginary part is y square minus x square by 2 plus k, and come here you can see the real part as xy, and also the imaginary part y square minus x square by 2 plus c. So that's it. So I think, or I am 100% sure about it, you will get the concept. You will get the concept through the more practice questions. You will get, I mean, you have the concept right now, but you will get the more accuracy in your concept, I mean to say, by having some more question related with the practice of your previous year question paper also, and directly with our workbook question also. So that's all related with the analytic function, my dear students. So in question number 8, question number 9 and 10, the real part is given and we need to evaluate the imaginary part. But yes, in the question number, you can say the 8th, the experimental part I have done with the real part. I have the real part, and by Milne Thomson method, I have the value of analytic function, but the conclusion is what? By putting the value of z in the function, which is the analytic function which I have got, by putting the value z is equal to x plus iy and taking the square and separating it, what I got is exactly in the form of the real part, that is nothing but xy, and in the form of imaginary part, that is nothing but y square minus x square by 2 plus c. So that's it related with the analytic function, my dear students. We'll have some more examples, in related with the analytic functions, and yes, I will give you some more concept which is related with the analytic function and entire function, and yes, will give you the more concept related with the singularities. This is nothing but the essential singularity and some more singularities like removable singularity. So this is the important part. I will take those part which are less important, you can say, after the complex integral. So firstly we need to have the basic, which have been done already. Now this is the completion of the analytic function. Now we should go for again important topic, right? So what I am going to tell you is the important related with the GATE examination, which is really important, is nothing but the complex integral, which is definitely asked in your GATE examination, and yes, it will be going to ask in your GATE examination as well. So in the analysis of previous question paper, you can have what the analytic function in the entire part of civil mechanical, or most probably in the mechanical or chemical, and the integral part in the electronics, electrical also, and also sometimes from the mechanical. But yes, I am 101% damn sure that these two parts are really important. Basics are also important, but yes, the singularities parts and the series expansion are really less important. So you can have basic knowledge about that, but yes, you cannot ignore it. Fine, you cannot ignore it, right? This is the topic. The analytic function is really important, and after this the complex integral is really important, and after this we'll have some less important topic also, but only read that topic. We have some questions, but please do not ignore that topic, as they haven't asked, means they in what we can say previous 25 years it is asked most probably 1 or 2 times. So yes, 101% those are the less important topics, but will cover because it is in our syllabus, so we cannot ignore that, right? So firstly we should have the important topic. In our next video I am going to start the complex integral, so you can have the topic complex integral in your copy. And before going to the topic, please make sure that you have done with your practice questions related with the analytic and basic part, so that we can have the what we can say the less burden in our mind while having the integral part. Fine. So firstly complete this part completely, then go with the integral part, then start the next video, which is nothing but complex integrals, my dear students. Okay.